Hey guys, we're going to continue with where we left off on yesterday's notes. Okay, was this example 3 regarding using Cramer's rule to solve the system of equations. Okay, it turned out to be a time constraint 1, right? We spent time just on determinants, and now we have the opportunity today to explore this one. Okay, so let's go ahead and look at the notes you took in class. Okay, a little overwhelming, but we're going to go and take a look at this example so it can help make sense for you guys. All right. The first thing we want to observe is that these guys right here indicate we're going to be taking the discriminant, okay, of these matrices. So the question is, how do we produce these matrices? And again, it's based off of those notes I just showed previously. All right. Now, one thing that just seems to have fallen off here is that this should have x equals. So the guy that's important is this d. Okay. It's the same d. So once you calculate it, you have it here, here, and then here. So let's go ahead and do that. Now, before I do so, like it is typically the case, it's good to label. So I'm going to label this one right here A1, B1, and C1. This is A2, B2, and C2. Alright, now that's going to allow me to substitute into all of these very easily. So let's take a look at D, and it's asking for A1, B1, so A1, B1. Okay, so negative 8. Then it needs B1, so I'm going to put negative 7. And it needs A2 and B2, so here's A2. And it needs B2, negative 9. So this is now where you would put it in the calculator just like yesterday. Okay, this is the discriminant, and it'd give you the answer there. Okay, I'm not going to go through that to save time on this video. Next, let's go ahead and look at some of these other ones. Okay. So again, this one's ready to go in the calculator. Now, as far as x equals, okay. Now notice at the bottom is d, okay, which is exactly whatever number you get here. So really, the focus is what's on top. Okay. Now for this one, okay, it needs a C1. So I'll put negative 1. It needs a B1, negative 7. It needs a C2, okay, which is a 5. And it needs a B2, which is a negative 9. Okay, so let me just check that. C1, B1, C1, B1, and this is C2, B2, right? C2, B2, okay? And same thing with this one, okay? You would hit that in the calculator, you get some real number like we've talked about, like what we've seen in class, and you put it over to this number you got up here, and that be x. Alright. I'll probably do D in a little bit here. I might do them all. Let me just kind of finish setting them up here. Okay. So D on the bottom for Y. Now let's go a little faster here. A1, negative 8. Whoops. I'm working with Y equals. Okay. C1, negative 1. Okay. A2, negative 10. And C2 is 5. Alright. I guess I wasn't going to do it, but it'll help you guys. Plus, they're kind of fun to do anyway, so let me go ahead and get them done after all. See if I can punch them in. Alright, so let's go and put these in here. Alright. I'm going to have to try and memorize some of these. Let me clear this screen. Alright. So, little calculator. Menu 7, 3. Alright, let me go and fill this bad boy in here. So 8, 7, 10, and 9. Okay, we got a 2. Let's go and put in the other ones. 1, 7, 5, 9. Whoops. Alright, going crazy here. Let's see here. And alright, let me verify here one more time. 1759. Okay. And 8, 1, 10, 5. 8, 1, 10, 5. Okay. 8, 1, 10, and 5. Okay, let me just do 8, 1, 10, 5. Okay, so I got my numbers 244 and negative 50. Okay. So let's go and log that in there. Alright. Not completely, I'm just writing them down here. Calculator said 244 negative 50. Okay, so I got them right. So this one's done. Okay, all I would have to do, though this one's done, I will talk about that. I'll put this one over 2. I'll put this one over 2. Okay, this is 22. This is 27.5 negative. And, okay, this is your x and y coordinates. So, according to the notes, okay, where are we? It says if d does not equal 0. Okay, so you guys will just have your notes to use in the future, right? If d equals 0, and you see what we did there, the numerator and the denominator, right? So let's go back here. Where is it? What it's talking about? Let me grab a different color. Okay, it's talking about this number here on top. These are numerators. That's what you want to focus on. Okay. Where are we? So at least one of the numerators is 0. You would have infinitely many solutions. Okay. If d equals 0 and none of those numerators I just circled are also 0, then you have no solution. However, our d does not equal 0. Therefore, it has one unique solution. So, in this case, it's got one solution. Alright, let's stick with the red pen. And that solution is the point x 22 and y 27.5. Alright, so that takes care of that one. What are we doing on time? Okay, hitting close to 10 minutes. Now tomorrow, the official lesson, okay, besides covering that problem, we're going to continue to factoring using the greatest common monomial. And now this is going to progress, so you really want to have your fundamentals down. If this is easy, excellent. But nonetheless, it's part of that step 1 of that progression, okay, meaning the problems will get more difficult and more demanding. So here, to factor, I think most of you guys would look at these two terms. How do you know they're two terms? Because they're separated by a plus sign, okay, or in the future, if it's a minus sign, that would make this guy a term, a plus or a minus, and then this guy a term. Alright. However, in this case, it would have been given this. So if I look at these two terms, what do they have in common? Okay, and I'm thinking in terms of multiplication. So he obviously is 5 times x, he's 5 times y, so both of them are being multiplied by 5. I can factor that out. Right? Why? Because if I go back and try and put this in there, right? So there's the answer. So I'm done. Okay, I just factored. Now if you wanted to check, and you should be checking, if I was to go in reverse order, I'd understand that I'm supposed to distribute the 5, so 5 to the x is 5x, plus I need to distribute it to the y, and I get 5y. Alright, this check is going to be very important. And next you'll look at a problem just like this. Same thing. Okay, the pluses separate the terms. So here I have 1, 2, and 3. And this could easily have been minuses, and I would still identify 3 terms. So here it's a little more complex already. So the first thing you want to look at is these coefficients up front. Okay, what is the greatest factor? Okay, the biggest number you can divide into each one of them. And after you take some time and think about it, you'll realize it's a 3. Now next is, I guess I can do it this way, is you have x cubed, x squared, and x. So there's a pattern there, right? They all had an x. However, the greatest amount they all have is an x. He has 3, however, in common, right? Greatest common factor would be, hey, he's got 3, he's got 2, he's got 1. What do they all have? At least 1. So there's that. Now once I've factored that out, what's left over? Okay, I need this 12 after I've divided a 3 out is left with a 4. This x cubed, after I divide out an x, I'm left with an x squared. Alright, and with that same train of thought, 9, factor out a 3 means 9 divided by 3, I have a 3. I have x squared divided by x, I'm left with an x. And lastly, I have 6 divided by 3, I'm left with a 2, and x divided by x is a 1. Okay, I could put times 1, or I can just leave it blank. So there's the answer. Now let's go back and check it. Very valuable to check it, because if that process was a little uncomfortable for you, okay, then this process should be a lot easier. So if I put that back in there, I should get 3 times 4 is 12. X times x squared is x cubed, plus 3 times 3 is 9, x times x is x squared, plus 3 times 2 is 6 with the x. And this should be a match exactly like this. Alright guys, thanks for your time.